All right, I think we're ready to roll.
And we are live. Welcome everybody to our second installment of the Service Mesh in the Real World video series featuring Sendip Parikh and Christian Posta. This time we're going to talk about multi-tenant ingress using Istio. So this is live streamed and this is recorded. So as these gentlemen are speaking and going through the different examples and demos, if you have questions, please pop them into the Q&A section on the YouTube Live, and then we'll get to them at the end of the session. All right, over to you.
Great, thanks Betty, thanks Jace. Hey folks, welcome to the second edition of Istio or Service Mesh in the Real World. So today we want to talk about how to do multi-tenant ingress using Istio. My name is Sendip Parikh. I'm working at Google Cloud. You can find me on Twitter at CRCSMNKY. I've also got Christian Posta with me as well, at Christian Posta on Twitter from solo.io. Why don't we get started here? So today what we're going to cover, we're going to lay out a little bit of the challenge that we're trying to solve for, some examples that are available, an example deployment that we can kind of work off of, and the example we're trying to solve for. Talk about some of the ecosystem solutions that exist, and we'll close with what's new in the latest release of Istio, and we'll have some time for questions at the end. So with that, let's start with the challenge that we're trying to solve for. So what we're hoping to do here is how to figure out how to run multi-tenant ingress deployments within a Kubernetes cluster. So what do people usually think of when they think of multi-ingress? Well, oftentimes, right, you've got large-scale Kubernetes deployments that are multi-tenant. So that means lots of individual workloads, services, applications, and that could also be served by many, many teams. And it's easy to see, like over time, those clusters can become very, very large, and each of those teams may need their own dedicated approach to ingress. They may need to serve different domain names. They may just want to have a clear and distinct separation between other ingress points that other teams may be using. But ultimately, in a large multi-tenant application, a multi-tenant cluster, individual applications or workloads may need, again, their own ingress approach. So what are some of the reasons why we see folks kind of going down this path of having multiple ingress approaches? First and foremost, we see it as a way to isolate individual teams and logical workloads. And again, a workload may be more than just an individual pod or service. Think of multiple applications being served out of a large cluster, and each of those applications themselves are composed of individual pods and services. So the isolation approach, right, could start at something like the namespace. So if you have different teams working out of different namespaces, over time, based on some of those requirements, those teams may again want their own ingress point. You may also want to be doing things like serving applications out of different domains. If you serve applications out of different domains, you may have particular requirements around things like SSL support. So that can be one aspect of it. And then for different ingress types, you may also want to have different services being served, like APIs versus end user facing services. And because of the way those may scale and operate differently, you may want them to use different infrastructure. Again, a different ingress altogether. So let's talk about an example deployment where this might make sense. So in this case, what you typically have in a Kubernetes environment is you may have, again, multiple applications. Each of those applications could be powered by multiple services, but you have a single ingress point, right? So typically what may happen is you may spin up a Kubernetes ingress resource or another ingress mechanism to get traffic from the outside back to those applications. So this is what we have today, right? This is a pretty common standard approach. What we want to get to is where each of these individual applications can have their own ingress mechanism altogether. So one that is logically and physically separated, right? These may run in individual namespaces, right? So each of those ingresses could run in a different namespace, or at least be controlled by applications in a particular namespace. And again, be configured very particularly for those application needs. Some of the top level requirements that we see, kind of mentioned this already, but it's a good recap. We want the ability to have this ingress approach or this multi-ingress approach support the idea of structuring our cluster where we can isolate teams and isolate logical workloads. Again, typically in Kubernetes, you do this via namespaces. We want to be able to support different types of ingress approaches. So I made the example earlier of maybe an API use case versus an end user facing service. And we want to make sure that each ingress approach we choose in this multiple view has support for SSL certificates or HTTPS, because that's a pretty common need for the most part these days. The features that we want to make sure we've got. So this is really important because this really ties into how platform native, right, this technology is going to feel. So we certainly want to be able to have platform load balancer support. That could be whether it's Kubernetes platform load balancer support or even any of the public cloud providers or private cloud providers. So we want to make sure we've got load balancer support there so that Ingress Gateway object inside of Kubernetes can actually be connected to an external load balancer. We obviously want to have SSL certificate support there. We do want it to function as much as possible like a Kubernetes native service. That means it should have, a stable API approach. It should follow kind of Kubernetes best practices around running this infrastructure. Now, in an ideal world, we'd like to have, sort of additional traffic management mechanisms that gives us the ability to kind of go beyond just a single entry point in the cluster into a little bit more fine-grained traffic control as we're routing to different parts of our applications or different backends. Another possible option would be, having API gateway support. This could also be a critical feature. And finally, we want to be able to support, where possible, authentication support for in-cluster services. And so if you're familiar with Istio, Istio has this idea of having mutual TLS authentication between individual pods and services in a cluster. And we'd like to take advantage of that if possible here as well. So let's talk through some of the available ecosystem solutions that are on the market today. So first, the one that we always will see on a pretty regular basis is Kubernetes Ingress. Obviously, it's more capable than using the service spec type load balancer. The spec type load balancer typically on most public cloud providers will spin up an L4 load balancer, whereas Kubernetes Ingress is meant for L7 load balancers, and it gives you a little bit more granularity around L7 paths and routing, et cetera. Typically, Kubernetes Ingress supports SSL certificates, so that's good. We can certainly deploy multiple Ingress resources, which is pretty handy. As I mentioned, it can integrate with L7 platform load balancers pretty easily. And it supports a pretty standard approach around single service mapping, a simple fan out across multiple backends, or a name-based virtual host approach. The challenge with Kubernetes Ingress is that it's really only part of the problem, right? If you write a Kubernetes Ingress resource, that structure, that manifest, actually has to be given to an Ingress controller, which does the actual physical service-based routing and fan out, et cetera. And so you need two parts of this problem, right? The Kubernetes Ingress resource and an Ingress controller. When it comes to Ingress controllers, there's quite a few options, right? There's a lot of them here, and we're not going to go through all these. We'll talk about a couple of them, but the point here is that there's a lot of options in this space. And so each of these options is going to offer a number of different features and functionality. Specifically, they will target what the Ingress resource supports, but they may also have additional features. So one of the first ones that we'll talk about really quickly here is Traefik. Traefik has a ton of great features, right? It's very tiny, it's very fast, it's written in Go. I think it lends itself to being a very, very quick and powerful solution. It actually has a particularly interesting approach here where they support the Kubernetes Ingress resource, but they also provide an Ingress route CRD, which means they take some of the basics that the Ingress resource provides, and they go a little bit further into more functionality, more flexibility, more capability with a specific CRD called Ingress route. But at the end of the day, this is really going to serve our Ingress only case, right? It does lack a couple of things that would be nice to have, particularly around some of the more, I think, particular traffic management mechanisms once you get into the cluster, some of the potential mutual TLS integrations. It can be used as an API gateway, but you may be pushing the limits of what Traefik can really offer at that point. So it's really just a kind of a pure Ingress approach. Nginx is another popular option that we see pretty regularly. It's probably one of the most popular Ingress controllers that Kubernetes deployments use. As you'd expect with Nginx, it's got a ton of great features. It's very much a tried and true technology with many, many, many examples and many questions and answers on Stack Overflow. But again, we're kind of left with the original challenge that Traefik had, which is it's an ingress-only approach, right? So it's going to help get traffic into your cluster from that L7 load balancer through its ingress controller back to your backends, into your applications or your workloads. But it's not going to do all of the kind of traffic management features that we may want to have, that we may already have access to internally with something like Istio. So this is a good solution, again, for getting traffic into your cluster, but beyond that, it's not giving us a bunch of the other things that would be nice to have as well. And so with that, I'll hand it to Christian.
Thanks, Sandeep. Let me share my screen. And let's pick up here. So we got a couple of examples here and discussed the power of some of those ingress options, especially on a Kubernetes cluster. And as Sandeep kind of hinted at, there are more powerful routing and traffic management capabilities that might be desirable, and maybe have them plug more natively in with Istio and the rest of the mesh capabilities. And so the question you might be asking, if you are looking at service mesh, and as you're looking at that long list of possible Kubernetes ingresses, is what's a good sweet spot for a Istio native solution? And you don't have to look too far to find a good option. Out of the box with Istio comes the Istio Ingress Gateway. Now, Istio, when it first started about 2.5 years ago, there was support, and I guess still is technically, for the Kubernetes ingress. But because of the limitations Sandeep outlined earlier, the Istio, or the Kubernetes ingress, is an option, but it doesn't come with more powerful capabilities like TCP support and advanced traffic routing and percentage-based traffic splits and so forth. And so that's where the Ingress Gateway comes into play. Now in Istio, the Ingress Gateway is driven by the gateway resource and the virtual service resources that you can use inside the mesh as well. It's basically a Envoy proxy that is deployed as a pod and exposed either through load balancers or however you want to expose it outside the Kubernetes cluster, and has, like I said, it brings more power. It brings the capabilities of Envoy basically to the edge, and ties in natively with Istio's mutual TLS support and the distributed tracing and observability and so forth. So with Istio Ingress Gateway, by default, you get a deployment of one single proxy or one gateway that has a horizontal pod autoscaler and can be scaled horizontally. But you might want to have multiple ingress points, as Sandeep outlined. Those are the various forces like isolation and SLA and so forth. You might want to create new ingress gateways and use those to drive the traffic to into the mesh. And that is possible with Istio. So like I said, there's one that comes out of the box, but you can use the Helm resource generation templates to create additional gateways. You'll have to kind of edit out some of the details and change them to align with the particular gateway names and labels and parameters that you want to give to it. But under the covers is another instance of an Envoy proxy that can be given separate configuration from any of the other ingress gateways. In this way, supporting the multi-tenant gateway approach that we're talking about in this particular video. When you go down that path, you're going to have to, there are a handful of sections in the config that you'll need to at least consider changing to get things up and running. You want your own service account, and you'll want the standard Kubernetes deployment and service resources to define your new ingress gateway. The last thing I'll point out here is that your new gateway will be driven using the same spec or the same APIs that drive the Istio Ingress Gateway as well as the rest of the mesh. Just make sure the names and the label selectors match up, and from there you have the full power of these particular CRDs to drive the configuration. Now, at Solo, we are working with our customers to bring the world APIs to their clusters, to Kubernetes, and have that work natively with Istio as well. So although the Istio Ingress proxy is great at getting traffic into the cluster, and it augments and supplants the Kubernetes Ingress resource with more powerful features, same does Glue to the Istio Ingress Gateway, where we can layer in more API focused features, things like message level transformation, things like Swagger support and gRPC reflection support, things like a little bit more advanced end user security flows like OAuth and OpenID Connect, edge-based security like web application firewall, so you don't have to rely, if you don't want to, on specific cloud providers or more expensive proprietary vendors and so forth. So Glue is our edge proxy that is also built on Envoy, so it inherits all of the same traffic routing capabilities that you would expect out of Envoy, including traffic splitting and traffic shadowing and so forth, and runs natively inside of Kubernetes. So Glue is also driven through CRDs, and if you don't want to run in Kubernetes, you can run outside of Kubernetes as well on VMs or bare metal or wherever you'd like. So Glue complements a service mesh, specifically Istio, because it extends the capabilities at the edge. It extends the out-of-the-box gateways that you see in Istio. It does integrate natively with Istio's mutual TLS. And in the case of the newer versions of Istio, we can plug directly in with the secrets discovery service, so that when we talk with Citadel and exchange certificates, we can have a more secure way of doing that with SDS. We can also integrate with Istio's telemetry collection and distributed tracing, and ends up providing a full API to backend service abstraction for your network. Glue, as I mentioned, is built on Envoy and can tie in with various environment components and systems that you might already have in place to kind of bridge your existing workloads into the service mesh workload, as well as fill any gaps that you might have when you get to service mesh when it comes to solving for edge problems. Now, let me show you a quick demo of using Ingress Gateway and using some other helper components to make it easier to deploy secure gateways. For example, using Cert Manager to automate getting certificates. We can use Istio's SDS functionality to, like I said, instead of manually mounting in volumes with secrets and so forth, we can wire up the gateway to talk directly to an SDS service and have the SDS service serve the certificates without any extra mounting of things on the disk, as well as exposing HTTPS. So let's take a look at that demo real quick. The first thing that we'll show is that we're going to use Cert Manager to define the certificates that we use in our cluster. So this will automate, in this case, talking with Let's Encrypt to, if we just take a look at some of the settings here, talk with Let's Encrypt, automatically get our certificate, create the secret, and feed that into Istio's SDS. So in this case, we're defining the certificate using Cert Manager. If we look at getting the secret itself, we can see Cert Manager automatically created the secrets and put them into Kubernetes for us. And then now Istio Citadel and SDS implementations will take over consuming these and serving them to our gateway. So if we look at the Istio system namespace, we can see that we have our Ingress Gateway here. If we look at the gateway resources, we have a gateway resource here called Hello World. And in this case, we're listening for a particular host. We're exposing it over HTTPS. And the most interesting part here is we're using the certificate that was created by Cert Manager and is being served over SDS. So the Ingress Gateway is talking over Unix domain socket to the SDS agent and is getting the certificates that way. The last thing that we'll look at is the virtual service, which then does the routing from the gateway. So the gateway will be listening on HTTPS, terminating the TLS there, and then routing to our backend service. In this case, it's Hello World. If we look here, we see we have Hello World v1 and Hello World v2. We'll be routing to Hello World v1. Now, I'll show you what the curl command looks like here. And if you take a quick look, we're calling the service, but we're also, and since I'm using curl, we're going to match on a particular domain ID, but we're using the zip.io DNS resolver here, so we kind of have to do a little bit of munging to make the gateway realize what DNS name we're actually using. And so we have to add a little bit of magic here with the resolve part of the equation here, but that's okay. If you had real DNS certificates and a real DNS provider, then you don't have to jump through these hoops. So if we do a curl on this, we are going to notice something not so ideal. If we look closely here, we see that the certificates are being presented, but that our local computer is not trusting the certificate fully. And that just happens to be because there's an intermediate chain certificate that is not included in the server-side certificate, and that is an issue with that I had setting up the certificate through Cert Manager, and that's something that we can fix. I just didn't have enough time for this demo. But if we momentarily, and you never want to do this, but momentarily just skip that intermediate chain verification, then we can see that it does succeed, and we do see our response from version 1 of our service. So that's using Istio's Ingress Gateway combined with some automation around certificate management and exposing HTTPS to the outside world. The last demo that I'm going to show here is so let's say that works great. We have some clients that use that, but we need a more capable API gateway and a more sophisticated security at the edge of our cluster, at the edge of our mesh. So we might turn to something like Solar.io Glue Edge Gateway. Glue Edge Gateway has a nice UI for creating new APIs, for configuring routing rules and so forth. We can see here we have a negative status or bad status here with the Envoy proxy that we're using for our gateway. And the reason for that is because we don't have any routing rules set up yet. So let's go ahead and set up a quick routing rule. If we come here, let's do demo. So this should add a new routing rule for our service that routes from the edge to Hello v2. So we'll treat this as a multi-tenant ingress solution here. We see that is pending. In a second, we'll be able to call it. Let's come over here, and we see that the health of our API gateway is improved because we're now exposing a proper route. And what we can see here now, if we do glue contel proxy URL and get this URL, we can call our v2 service, and we see that Hello v2 works there. But the important thing to note here is that Glue's gateway is actually tied in directly with Istio's SDS service. And one way we can show that is if we look at the gateway deployment here in Kubernetes, we can see that we're actually mounting the SDS Unix domain socket into the glue proxy, which is basically Envoy. And let's see if we can get out of that. And then if we look at how we're talking with the Hello World v2 service, we can also see that the configuration, we're pulling the configuration directly from SDS and not the mounted mutual TLS tokens that you see in Istio. So coming back here, let's wrap up the demo part at least. So what we did was we implemented a multi-tenant cluster using various capabilities from Istio native gateways. Both in this case are built on Envoy, and but you can pick the one that's most appropriate for your use case. So from that, I'll share back with Sandip, who will go over what's new in Istio 1.3.
Awesome. Thanks, Christian. So let's talk about what's new in the latest release of Istio. So Istio 1.3 was shipped about September 12th, so just about a month ago, roughly. It had 52 kind of major improvements, covered a series of commits, about 600 plus commits. And over the course of Istio's lifespan, we've seen about 400 contributors, 400 plus contributors actually, coming from 300 companies. And the reason we like to highlight this every time is because we want to remind everyone in the community that there is a long tail of contribution coming from a lot of different areas. It's not really driven just by one or two sort of big entities. There's a lot of community contribution. And to be honest with you, we would welcome additional community input. The community meetings, notes, working groups, everything is up on GitHub and out in the open, and we would love to have more folks, even more folks, attend the community meetings and share their experience, get on the Slack, participate, because there's a lot of work to do. There's always documentation updates. There's always room for new blog posts. We'd love to have more of those. There's a lot of work out there that we want to share, and we'd love to get folks involved in. The link to the full release notes is there, and when we post the slides, that link should be clickable if you want to dig into it. But I did want to highlight a few things that we thought were really important. So Istio's key themes for 1.3, if you remember for 1.2, it was really around a lot of internal machinery. How do we improve a lot of the internal processes to make releases more predictable from a quality basis, more predictable from a timing basis? So now that work is done with 1.2, we kind of turned 1.3 and took a look back outward and said, how do we improve the user experience for new users adopting Istio from day zero here? How do we improve the user experience for debugging challenges that do come up with Istio, right, with configuration? There's still a large API surface, so a lot can happen. We want to make sure that we give you all the tools that you need to debug those problems. And then we wanted to focus on how do we support more applications without having to update configuration or without additional configuration altogether. So those were the three kind of key themes for Istio 1.3. And so some of the highlights, particularly around, I think, some of the UX and sort of additional configuration need for applications, is one of the biggest ones is that container port is no longer required in your deployment spec. So in the past, we required you not only to have a particular port naming convention so that we could figure out protocols and go from there, but we also required you to specifically highlight your container port. We have removed that requirement altogether, and this was a change that had been introduced a few releases ago and is now a GA feature. So this is a particular new feature, which is really nice. It's one less thing you have to change from before using Istio to using Istio altogether. We've also made it possible to customize more easily the generated Envoy config that we generate for use in the Envoy sidecar proxies. And then there's a host of interesting experimental features, which kind of sets us up for the future. And I want to talk through those really quickly as well. The first one is mixerless telemetry. So what that means is now we've got a setup where you can configure the sidecar proxy to bypass Mixer altogether for telemetry and actually report telemetry information, so that's tracing, logging, and monitoring data, to your backend infrastructure for those services directly from the proxy. So it no longer goes through Mixer, which is this kind of single, sort of single point of kind of in and out, which has led to, potential performance issues in challenging configurations, things like that at super high scale. So instead of having to tweak Mixer for those high performance scenarios, we've just kind of wanted to start this path of removing Mixer from that path altogether. And so that's a really big feature. We'd love to get more eyes on that and have more folks test that approach out. We've also added intelligent protocol detection. So if you remember, I mentioned earlier, we require you to name your ports. It's a key requirement for pods and services to become part of the service mesh. We're actually starting now work on, can we intelligently detect the type of connection you're using so that we don't have to have you name the protocol itself. So instead of naming your ports HTTP or HTTP dash something or other, we should be able to detect that it's HTTP traffic. And so that's what we're working on as well. And so there's some support in there today for a subset of the total protocols that Istio supports, and more are certainly coming. But again, this is another feature we'd love to get more eyes on. Another very popular enhancement, I think this was driven by not only users, but also from the engineering team building Istio itself, is they wanted to move to an operator-based install that was a little bit more in line with how they saw the system growing and maturing over time, and to drive better experience around things like upgrades, et cetera. And so the operator-based install, again, is experimental, but it's available today. And that one is actually executed by the next one, which is Istio CTL experimental. So there's a couple of new things in Istio CTL experimental. First one is obviously the operator-based install approach, but then we've also added a bunch of really interesting debugging capabilities. Specifically, if you run Istio CTL X or experimental, right? X is just an alias for it. You'll see all the available commands that are in there. And there's actually been quite a few that have been added in Istio 1.3. And I want to focus on two in particular, which are pretty awesome. So the first one is analyze. This is one of the first releases where we have Istio CTL X analyze. And what it will do is it will actually analyze your YAML files, not just for API adherence or API conformance, right? We were able to do that already with the Istio CTL validate command, but with the analyze command, we're actually able to tell you what's going to happen, what these YAML files are going to do to your cluster. We could also actually point it to a live cluster and say Istio CTL X analyze, and analyze the current kube config that you've got configured, and it will go and analyze the running live cluster and give you a readout of any of the configuration problems you might be having where, again, individual manifests, individual API objects may be configured correctly, but when you put them together, it's causing some kind of conflict. And then the third part of that, which is I think the best part, is you can actually now simulate the effect of applying the YAML that you've got there. So you can actually combine the first two, analyzing YAML files and analyzing a live cluster, and then see a simulated impact of saying, well, take my running cluster, and simulate the application of these one or two YAML files and show me what's going to happen to the cluster. Tell me if it's going to break things. So this is a really powerful feature, and this is just the beginning. And this is a bunch of work that came out of a separate working group that spun up and was very open and interested in feedback, and they took a lot of good approaches and they applied them to this analyze functionality. So this is a growing area, and we're hoping to see a lot more work come out of here. But the point being, we can do a lot more to get out in front of potential configuration issues. The second one, this goes back to my previous comment around the operator. So the Istio CTL experimental manifest command is the basis for the operator-based install. And it lets you generate all the manifests you need to apply to your Kubernetes cluster to deploy Istio. Or you can actually generate and apply them right in line. But it also gives you the ability to diff against multiple different installation profiles or manifests. So if you really wanted to dig into the differences between maybe the default installation and the SDS configuration, you could do that. You could also figure out how to dive into migrations from things like migrating from the Helm approach to the operator-based approach. So there's a bunch of different options here that are really powerful to again, change how we do the installation process and move to this kind of operator-based install. So again, another area that we think is going to grow quite a bit, and we would love to get more eyes on for testing. And just as before we close, we want to talk about what's coming up next. We've been running on the schedule where about 3 to 4 weeks after individual Istio releases, we have kind of service mesh in the real world topic. And so for the next one, we're targeting kind of a security-centric, I think, example, where we're going to dive a little bit deeper into authentication and authorization with Istio. And the timing for Istio 1.4 is somewhere around late Q4. I think right now they're sort of targeting just before Thanksgiving, so about mid-November. So we may have the webinar either early December, or depending on interest, we can maybe wait till January when more folks are back from vacation. But our plan is to focus on security for the next session.
Cool. And
with that, we'd love to, oh, go ahead, Betty.
Sorry, I was actually going to say, we have security lined up as kind of the next one, because we were talking about traffic leaving the cluster, traffic coming into the cluster, and how we can secure that as a next step. But if folks have specific questions or use cases that they're interested in exploring more, please do just, you can post them on Twitter, tag us on it, or even, in the chat window here. That's something that's input we want to take to make sure that we create demos and scenarios that you may be thinking about or you are looking to do, and just want to see how Christian and Cindy kind of put those two together. So with that, any questions out there? There was one that came in through a different channel that's like talking about HTTPS and kind of setting that up. If you guys want to go into that one a little bit.
Yeah, so both in our demo, both the Istio Ingress Gateway as well as the Glue Edge Gateway support HTTPS, and both can be automated with Cert Manager to provide those certificates. So I kind of tried to show how that works in combination with Cert Manager. Couple things to keep in mind is that Istio can do Istio Ingress Gateway or Envoy at its core. So basically both Istio and Glue can do this, is support SNI. So we can support multiple virtual hosts and support multiple certificates serving from one single Ingress Gateway. But like we talked about, some of the forces at play here, there might be reasons to separate that out into multiple gateways. The second thing is that we could also do mutual TLS at the edge here with Glue or Istio Ingress Gateway, and so the settings for that are fairly similar. So you got to supply the server side certificate as well as the client side trust CA. But so both approaches support HTTPS.
Yeah, and the demo link that we've got here will go through how to set up the first, obviously the out of the box Istio Ingress Gateway, and it has some instructions on how to create a second Ingress Gateway, like an example one that you can use. And so what we'll be adding to that repo over time is more of the steps to set up Cert Manager and HTTPS. And Cert Manager is a component that's actually also included in the Istio release itself. It's part of the Helm chart already. So that's actually there out of the box, and it includes the CAN configuration with Let's Encrypt. So it's already ready to go to start doling out certificates immediately once you've got DNS infrastructure set up.